Video presents the work EMA, a Brazilian Cultural Heritage Image Dataset, towards AI-based metadata annotation of digital collections. I am Vagner Inácio de Oliveira, one of the authors of this project, along with Professor Paula Costa. We are from the Department of Computer Engineering and Automation of the School of Electrical and Computer Engineering of the University of Campinas. This project is being carried out in partnership with Professor Dalton Martins from the University of Brasilia. Digital collections are a powerful way to open museums' cultural heritage to exploration by the public. They are particularly relevant in a country like Brazil, where museums that preserve the country's history are thousands of kilometers apart, making them inaccessible to most people and difficult to study by historians and researchers. It also plays an essential role as a strategy for preserving cultural heritage. For example, in Brazil, three museums caught on fire in less than a decade. This kind of disaster unveils the lack of resources faced by many museum administrators worldwide, especially the smaller ones. Usually, the process of cataloging an object is complex and involves several specialized professionals recording and annotating the arrived item to archive it in the museum's collection. Nowadays, a specialized professional can catalog approximately 7 objects per day. This process, this process is complex, time-consuming and labor-intensive, frequently leading to high costs, human failure, and misunderstanding. To tackle this problem, the main objective of our work is to develop artificial intelligence technologies to help museologists improve the overall quality of digital collections annotations tool. In particular, the present work focused on building a consistent dataset from the Brazilian Museum's digital collections to feed a deep learning model to suggest related labels to the objects. To this, the data was gathered from Brazilian museums. The Brazilian Institute of Museums uses the Tinacan platform to publish to the public. The Tinacan is an open source repository platform for creating digital archives in WordPress that also enables programmable access to the database items. Here, it's possible to see an archive page from a confidential museum that shows the structured objects with their respective metadata throughout Tinacan. With this approach, the data from Brazilian museums were gathered. A pre-processing step was carried out to obtain the desired dataset, and then fed into a deep learning model to classify the objects according to their label. The metadata is structured as follows. It is possible to gather the data from every archive page, straight from the Tinacan API, HTML, a CSV, JSON, or a PDF. The JSON format was used, which is displayed by each lines. Each page, in this case, contains 96 items. One of the items is illustrated, and the related image is gathered with the URL inside the JSON. The dataset construction steps used to refine the data to obtain the desired dataset are illustrated in the following diagram. First, the data from digital collections of Brazilian museums was gathered with a Python script, gathering the text data in a JSON format, which consists of over 15,000 objects. After that, the most frequent thesaurus terms were selected as the main target. From that, we filtered the database, keeping only the interior objects, which consists of 2,922 items. With the target items at hand, we analyzed which metadata field could be used to label the corresponding images. We found that the most consistent term is denomination. This field is the best one that describes the objects. Once again, we faced many terms used to describe the interior items of the collection. So we decided to analyze the most frequent words used to describe the objects. As a result of this analysis, we kept 31 frequent words as image labels. To ensure that our dataset is consistent in classifying cultural heritage objects, we built an image classifier that relies on the pre-trained network ResNet 50. Adopting the transfer learning method, we trained the final layer using the original images. We used 80% of the images to train the model and the remaining for validation and tests. The model was applied with FastAI, an open source deep learning library that is built on top of PyTorch. The training and validation accuracy at the end of 6 epochs was 86.7%. The most confusing classifications are summarized in the table, which shows the methodology's limitations. For example, the method resulted in 4 labels to identify cutlery: fork, table knife, spoon, and cutlery. Those 4 labels resulted in many misclassifications since the cutlery label englobes fork, table knife, and spoon. We presented our first steps towards the development of AI-based metadata annotation tools. We showed EMA, a labeled image dataset with over 11,000 images of historical objects found in 17 Brazilian museums. We also presented a baseline results for this dataset through a ResNet 50 deep learning model training with 86.7% of accuracy in object recognition. The forthcoming works include exploring the performance of other deep learning architectures and increasing the dataset with other cultural heritage collections towards a generalization of the model. It also planned to develop an application that suggests labels during the annotation process. Thank you so much for watching, and please check our paper and contact us if you have any questions.